Part 3, Determining End Behavior and Zeros. Let's talk a little bit more about the end behavior and how to write it using correct mathematical notation. So let's think about if we have the end behavior of the graph of f of x equals ax to the n. If our degree is even, so our exponent there is even, you can kind of think of x squared. We already know what the graph of y equals x squared looks like. So if a, our leading coefficient, is positive, then it's going to go up on the right and up on the left. But if our leading coefficient is negative, or less than 0, then we can think of negative x squared, where we're going down on the left and down on the right. So anytime our exponent is even, we can think of a graph of a parabola to determine the end behavior. Now, if our degree is odd, if we can just think of y equals x cubed and negative x cubed, we know what the graph of y equals x cubed looked like. So it goes up on the right and down on the left. And y equals negative x cubed is the opposite. It goes down on the right and up on the left. So anytime we have an odd degree, we can think about the end behavior of x to the third, and it will be similar. Let's look at what that mathematical notation looks like. We might say, if we just have y equals x to the third, so our graph on the left here, as x approaches negative infinity, y approaches negative infinity. This means that on the left side of the graph, as x approaches negative infinity, so on the left side of the graph, what's happening? Well, y is going down, our graph is going down, so y is approaching negative infinity. And as x approaches positive infinity, y is approaching positive infinity. So that's on the right side of our graph. As x approaches positive infinity, that's the right side. Then our graph is going up, so y is approaching positive infinity. Let's look at that for the other graph. If we have y equals negative x cubed, we might write as x approaches negative infinity, y approaches infinity. That's the left side of our graph. As x approaches negative infinity, our graph is going up, so y is approaching positive infinity. And as x approaches positive infinity, y is approaching negative infinity, because on the right side of our graph, we're going down. The end behavior of the graph of a polynomial function will match that of its leading term. Describe the end behavior of f of x equals 2x cubed plus x minus 5. We can look at the end behavior of just the leading term, and our end behavior of this whole function will be the same as if we just had 2x to the third. Now that leading coefficient is positive, so we know on the right it's going to go up, and our degree is odd, so on the left it's going to go down. So we might say as x approaches infinity, y approaches infinity, and as x approaches negative infinity, y approaches negative infinity. The reason why is because our leading term is positive and our degree is odd. So on the right side it's going up, on the left side it's going down. Let's do the same with this one. We have 2x to the fourth minus x squared plus 1. So the end behavior will be the same as if we just had 2x to the fourth. Now that is a positive leading coefficient. So as x approaches infinity, y, or g of x, approaches infinity. It's going up on the right side. Now as x approaches negative infinity, what's happening? Well, our function here, we have an even degree function, which means the left side's going the same direction as the right side. So it's also approaching infinity. Let's describe the end behavior of this function right here. We have 2x times 3 minus x cubed times 2x plus 1 squared. So our leading term would be if we just multiply the first terms of each factors raised to that power. So 2x to the first power, negative x to the third power, and 2x to the second power would give us 2x times negative x cubed times 4x squared. Remember that a negative raised to a power, if the power is odd, it still stays negative. So we get negative 8x to the sixth power. So we have a negative leading coefficient, and the degree of our polynomial is even. So as x approaches infinity, h of x is approaching negative infinity. So that's what's happening on the right side when x approaches infinity. And as x approaches negative infinity, so that's the left side of our graph, then h of x is approaching negative infinity. It's going the same direction as what's happening on the right side because we have an even degree function.